we need to find out what the Jacobian matrix of this vector function is. What is the Jacobian? It's when jxy would be represented as df over dx, df dy, dg dx, and dg dy. These values of f and g are arbitrary. You can put dp or dq. You're just assigning this as f and this as g. So let's get on with it. So we know that f is x sine xy. And that means to do df dx, we would use the product rule on this, and you would then get xy cos xy plus sine xy. Let's now do df dy, which is a lot easier because it's going to just be x squared cos xy, because we've held those x terms constant. We're only looking at the y terms. And now let's do dg dx. Similar to before, we've got two parts here, so we would use the product rule. You should be familiar with how to deal with the product rule. So dg dx of this function would be x squared ye xy plus 2x e to the xy. And then we will have dg dy, which is pretty straightforward, x cubed e to the xy, because we're only differentiating the y terms. Now, all you have to do is plug them in here. So df dx is xy cos xy plus sine xy. Here would be x squared cos xy. Here we would get x squared e to the xy plus 2x e to xy. And here would be x cubed e to the xy. And that is all in a matrix. You could find the determinant of this matrix, and there's lots of other things that you can do, even eigenvalues or whatever else. But if you want to find the Jacobian matrix of this vector function, you would stop here.